Hi everyone, welcome back to our channel. Today we are going to solve this problem. The given problem is two sinusoidal currents are given by the instantaneous values of 10 sine omega t plus 60. So the standard format is Im into sine omega t plus 5, and next current I2 is equal to Im sine omega t minus 45 degrees. So when you see here, this I can write down the phase difference. Okay, so the phase difference between I1 and I2 is nothing but how much? First one is 60. Difference no, minus of what is this angle? Minus 45 degrees. Okay, so 60 minus into minus is how much? 45, which is nothing but equal to 105 degrees is the phase difference. Now how to plot? Okay, and calculate the phase difference, we calculate it and we need to plot it. So when you are plotting, you have to take one axis as a reference, voltage at an angle 0. So first let's try to represent it in polar form. So when you are representing in polar form, we should use only RMS terms. Okay, so here this is the maximum term. So maximum term divided by root 2 is the RMS at an angle 5. What is that angle? 60 degrees. Okay, next one, how to write down for current I2. Okay, so I can write down this as the current. So this is maximum value. Okay, so this is nothing but when you write down in polar form, this is nothing but RMS quantity, that is divided nothing but maximum divided by root 2 with an angle 5. What is this angle here? We are going to get minus 45 degrees. Okay, now let us try to plot. Okay, so voltage at an angle 0, and here we are having plus 60. So plus 60 means it's nothing but it will travel in counter clockwise direction. So this is the magnitude of current, which is nothing but having a magnitude of 10 by root 2. The magnitude is how much? 10 divided by root 2, and it is traveling with an angle of plus 60 degrees. So I can say this is like a current across the capacitor. And the next current I have is 15 by root 2 at an angle of minus 45. Okay, so here when you draw it, the magnitude of this waveform is 15 by root 2, but the phase angle, so when you're traveling in uh, counter clockwise direction, the reference you have to take it as positive degrees. When you're traveling in clockwise direction, you should take it as minus 5. So here this is how much? Minus 45. So the overall angle, or where we call this as the phase difference. Okay, so the phase difference is now, so 60 minus of minus, it is nothing but the phase difference. Now we are going to have as how much is 105 degrees is our phase difference. That's how to calculate. So if you mark this current as I1 and this current as I2, what is leading? So you can say here I2 lags I1. I2 is lagging I1, where I1 leads by how much angle? 105 degrees. This is how to calculate the phase difference between the two currents, I1 and I2 current, where I can say this I1 is the current across the capacitor, where I2 is the current across the inductor. If they're in phase, this will be an resistive. So like this we have to consider. So when you get the confusion, very simple. When the phasors are rotating in counterclockwise direction, you should take it as plus 5. When the phasors rotating in clockwise direction, you should take it as minus 5. That's what the concept of this problem. So we calculated the phase difference and we identified which is lagging, which one. I2 is lagging I1, and I1 leads with an angle of 105 degrees. This is how to understand. And one more point you have to understand in this problem is when you are representing in polar form, you should write down only RMS. Okay. So the RMS value is nothing but, anyway, if you write down the RMS, RMS is nothing but maximum value divided by root 2. So maximum value will be generally 100 percentage. 100 by root 2 will get 70% of that value. Okay. So that's why when you're writing in polar form, you have to express only in RMS. Okay. So that is the importance of the problem. If you feel my explanation is good, please like the video and share it with your friends who also are studying the same subject. And if you are watching the channel for the first time, subscribe to my channel with the name KV Tulasi Ram. Kindly support this type of free channel for development of students and faculty. Thank you for watching. Viewers obediently. Ram will meet in the next video. Thank you.